globally renowned organization dedicated to advancing science and technology. It got established in 1945, and I believe it has been at the forefront of innovation of artificial intelligence, quantum computing, cloud computing, security, and much more. With multiple research centers worldwide, IBM Research continues to drive scientific progress, helping industries solve complex challenges, developing cutting-edge solutions in fields healthcare, finance, and energy. So from the Bangalore IBM Research Center, we are having this courses getting designed and then delivered for PALs to the institutes. Over the next 4 days, what are we going to do? We have an exciting line of sessions that will take a deep dive into generative AI and its application. So we are having four day sessions are there starting today. But what are we going to do today? So today we are going to talk about generative AI. Who is going to talk today? Today's session will be led by Deepak Vijay Kirti. I welcome Deepak Vijay Kirti for this session, and then thank you very much for accepting and then to deliver this thing to all our college faculty as well as students. A research software engineer at IBM Research Lab, Deepak has worked extensively on auto AI and trusted AI. And more recently, he has been involved in building foundation models that can analyze and reason over the tabular data. He's working since 2015 with IBM. Before that, he was working in Microsoft. So before just handing over it, what is generative AI? Generative AI leverages advanced models such as large language models and diffusion models to generate text, images, code, and even audio. It powers a wide range of applications from chatbot, content creation, to design and simulations. It even gives code. Probably most of you know that how we can create a code for writing, etc. Indeed, in today's session, Deepak will introduce us the world of generative AI, focusing on LLM. So LLM model for IBM is Granite, and then Granite series. With that one, how that generative AI is going to work, and then what is that. So we are excited to have you all here, and we look forward to an engaging and insightful session. Let us get started. Over to you, Deepak.
Yeah, thank you for your kind introduction. So in this session, we would be taking a closer look into what are large language models. We will sort of trace the history. We'll start with how they evolved from where they started, what kind of models were there initially, what were the uses for those models, and then what were the deficiencies from the models, then which got solved by large language models. Hopefully, at the end of the session, you have a very bird's eye view of what large language models are, how they are built, and what are the intricacies involved. Just have an intuition on how to, and then perhaps if you have any questions, you could just ask me, I could take it.
Mr. Deepak, sorry for the interruption. So if you want to interact with the participants, you can tell that. So we will enable the chat box. So at that time, we will enable and we will have some questions or answers for something.
How do we do that? I mean, can we?
Yeah, we will enable. You just give a.
I have already marked where questions are for Slido.
That is that Slido is there. Suppose if you have want to ask any questions, general questions or something like that, if you want.
Sure. I mean, are you okay? So let's go ahead.
Kishore and myself will be here only, so you can ask if you want to ask any questions to enable chat or something. Thank you.
Yeah, thank you. Let's get started. Yeah, so we'll start with the most popular thing which basically started all the narrative in the public domain, which is ChatGPT. So in late 2022, OpenAI released ChatGPT, made it public for people to access. Then, and every player or every company has then started building their own LLMs. They build their own set of tools on top of LLMs, and they, in many senses, have started surpassing humans in some subset of tasks, or they match the performance, or in addition, they also help you improve in certain set of domains. They help you do better, they improve your productivity and whatnot. So these are some things which started coming out when LLM ChatGPT actually got introduced, is like how the LLM ChatGPT can write code, and how it can go and write exams for you, and how it does better than many of the average human performance. So before that, so just a very small snapshot on how it all started. The field of artificial intelligence started around 1950s, where the whole idea is to generate intelligent machines that sort of can mimic human intelligence, or in many cases exceed them. So then there have been a lot of work on how to build such systems. There have been early work on chatbots where people can go and interact to a machine, they can chat based on certain, but they were all limited to certain domains of expertise. For instance, there were chatbots which offered help for so send emails. There were chatbots which would take in your symptoms and tell some sort of diagnosis on what kind of diseases you had, and so on and so forth. Then around 1990s is when things have started becoming a bit more mainstream, when the next phase of AI started, which is called machine learning, where you look at historical data, you look at the patterns which are present in data, and then build models to help you make decisions, and it helps you to predict certain events. For instance, the early kind of spam filters which you see in Gmail were built using ML algorithms, where whenever a new mail comes to your inbox, you process to the ML system, and that decides whether the mail is a spam or not. So that's one of the large-scale early applications of ML models. So once then ML started coming into the main narrative, people started building more and more diverse set of models for diverse set of applications. In around early 2015 types is when deep learning came into the popular narrative, which is all about building ML models using neural networks. So once we started using neural networks to process really large amount of data, we started understanding or building models which started performing really well, which can be deployed in the wild. So for instance, many of the Google Translate systems you see are even the earlier Google Translate systems which you used to use are based on deep learning based algorithms. So people started figuring out how to train these models on really large corpuses of data, how to deploy them on scale, and so on and so forth. And the next iteration started in 2021-22 is where we started building generative AI. In that case is that instead of us building specialized models, for instance, we had to build models just to do machine translation between certain set of languages, some other model to do sentiment analysis, some other model to do spam classification, for instance. So then the next generation of models which came into picture, which can actually do multiple tasks at the same time and also handle multiple modalities. For instance, the model can generate audio for you, the model can generate images for you, or it can take images and you can ask questions to the model about the image you have given, and so on and so forth. So that's then the current iteration of the model where we are, and we are seeing even though they are in the nascent stages, we are seeing a multimodal interaction, as opposed to initial set of interaction was happening through text. Even now we can interact through images or audio or video, for instance, too. So that is the next generation of models which are coming, where you interact by itself with a different modality other than text. I think that's the very higher level overview of how things evolved. And there are a lot of applications which has come into picture, right? The simplest application is that you give a bunch of text and you ask the model to summarize the salient points of the image, where here, for instance, you are giving a article, a snapshot of Wikipedia, and I asked ChatGPT to summarize it for me, and it just creates a succinct summary of it. And if I don't like it, I can always ask it to regenerate, and it basically learns based on the feedback we are giving. Whatever feedback we are giving gets recorded in the system, and that is used for train the further iterations of the model. The other example is to basically generate a code, right? Instead of writing simple repeatable code, what I could do is that I can ask the model to write code for me. For instance, here I am just asking a very simple question, say write the sum of two numbers, it takes and just basically writes a Python code to generate. It also gives I can also go and interact saying that, can you add more complexity? Can you regenerate? Can you generate instead of Python and instead of generate it in C++, generate it in Java? Yeah, the options are plenty, and you just interact with the model and it outputs based on its knowledge. It generates complex code, or it could be simple applications. For instance, people have used to generate web pages from scratch. Or they have used it to generate more and more complex algorithms code from scratch. So you can start it, and then you can just basically have a conversational around it. And based on your conversation, it iterates over the code it generates, and then you get a better and better version of code as you go forward. So these are the simpler applications of modeling. So, and again, so the largely speaking, there are popular set of models fall into 4 different categories. One is called an embedding model, where what happens is that all you want to know is how the documents are placed. You want to build a representation of whatever you have. For instance, you have an image. Uh, Excuse me, are there any questions?
No, sir.
No, no.
Well,
Noise in the background. I request.
Okay. Yeah. So there are applications where I want to generate a representation of whatever object I have. For instance, let's say I want to do an image search. I'm sure people have done Google image search, right? You take an image and you put it in Google, and it tells you, it tells you where the image is, what the image describes, where is the image from. It also outputs similar set of images to that. So for generating a similar set of images to the image I upload, I need to generate some representation which the model understands. So that's what the use of embedding model is. It takes an object and it generates a representation of that. So basically, it generates an n-dimensional representation of an object as a vector. So, and the other class of models are text generation models, where you basically ask the model, you give a prompt to the model, and you ask it to do. For instance, that here I ask the model to write a leave of absence letter. It basically generates based on the data is seen. It has generated a leave letter, for instance, a leave of applications here. And the next class of models would be something like a completion kind of model. So I can ask it to give an incomplete sentence, and I ask it to complete it, for instance. That would become some sort of a chat, like what we looked at one of the applications, right? Where
share பண்றியா?
So for instance, I can go and interact with the model. I ask a question, the model responds, and I again go back and ask another question. Based on that, the model generates better response. Or there are other class of multi-model generative models where, for instance, in this case, I give a prompt. For instance, I'm just giving a prompt like a painting of a flying dog. So it generates an image which looks like a painting of a flying dog. I could also do such things for different modalities. The most popular one is image. There are also work on video generation and 3D object generation or audio generation. There are models which also generates music. You can basically give a prompt and it will generate music for you as well as lyrics, for instance, based on the prompt you're generating. So these are the popular class of models. And yeah, so how do we go about Slido here? I mean, we can start the question.
Do you want to run this slider now itself, sir?
Yeah, I mean, let's do it while we are doing the slides, if it's better.
Ask the 10 questions.
Excuse me?
No, you want that each questions or that because in Slido we will run whole 10 questions. Once,
okay. So then I mean,
so once you are done with the presentation, so we will run that.
Okay, perfect. Okay, then
Or in the middle of this also, it's okay.
It's okay. Then if you're going to give it at one shot, yeah, sure. Maybe I'll skip.
Yeah, because you are going to cover all the 10 questions in that, right? So
yeah.
Okay, fine.
Cool. Yeah. So in this lecture, we would particularly look at how text generation models have evolved, how they started, from where they started, and what was the initial set of models which were used for text generation, and how they evolved, and where are we now, and how do we train an intuitive understanding of how these models, the larger language models today, are trained, for instance. Right? So whenever you say a language model, it just means that it's a model which basically assigns a probability to given a sequence. For instance, consider the sentence, it's raining heavily today. So I want to see how probable this sentence is. So that's what the model tells me. Whenever I give a sentence, it tells me how probable the sentence is. A sentence which is grammatically correct and semantically correct will have a higher probability as opposed to a sentence which is erroneous. So that's the whole idea of language model. Now the question is, how do I compute this probability? How do I make sure the grammatically sentence and meaningful sentences get high probability and the ones which are incorrect or erroneous don't get a high probability? They are assigned a lower probability. So that's what the entire idea is about when you come to learn models. So like I said, you want high probability to grammatically correct sentences and low probability to ungrammatical sentences. So just to take a step back, language models have existed for a while and they have been part of production or deployed systems for quite a while. So the more prominent ones are like what I mentioned, which is Google Translate, where you give a sentence in a source language and you ask the model to change it and translate it into another language. For instance, here I'm giving a sentence in English and I'm asking it to be displayed in Hindi. Or the other more prominent example is basically what you see in your mobile phone day by day. When you say give a sentence, when you start typing, it start automatically give you suggestions, right? So was one of the earlier applications of language models. All these suggestions, the keyword which are wired into your keyboard, are done based on language models. So basically, whenever you start typing, it starts generating the most probable next word. So that's what the entire language models are about. Whenever you give a sequence of words, it tries to figure out what is your most probable next word you are going to input. So if you see here, help me buy a, so it gives you three possible options: house, new, or a car. So based on that, I can select, and based on that, also the model also tries to learn everything you give as an input. That you basically would go as training data for a future iteration of a model. So okay, let me go ahead. So what happens is that, so that's where we'll first look into evolution of language model, where it started and where we are now. So these are the earlier set of models. The language model by itself, the framework started around 1990s, where initially what we did was all about making sure that we started with the same aim, right? I want the grammatical sentence to be high probability as opposed to the ungrammatical ones. For instance, sun rises in the east should have a higher probability than sunrise in the east, or sun rises in the east should have a higher probability than sun, which is SON as opposed to SUN, where semantically SON doesn't make sense because the sun never rises. So that's the whole idea here. And we started building models with a very, very simple idea. So what I would do is that, let me see that I assume that I have seen the sequence of words. For instance, let's take the example when I'm typing in a keyboard, I'm typing on mobile, I went to the, and I want to find what is the next probable word. So what I would do is that out of all the probable words, which is possible, I compute the probability of the next probable word. And how do I estimate it? So now the problem is that I've already typed in, the model has to estimate what is the probability of the market. Or in another word, put it to other way, that I want to calculate the probability of what is the probability of I went to the market as opposed to I went to the ground, so that I can compare and give a better suggestion to the user. So what happens is that then what I do is that I sort of decompose the problem. Instead of calculating for the entire sequence, I basically started with what is the probability of I. Then once I've already generated I, then what is the probability of when, given the first word was I, and so on and so forth. I keep doing it recursively. So I start with a single word, then calculate the probability of the next word based on that, then probability of the next word based on the first two words, then the probability of the third word given the first three words, fourth word given the first three words, then fifth word given the first four words, and so on and so forth. So the simplest way is basically look at, so now the question is, how do I get these probabilities? So what used to happen is that in earlier days, Google, what they did is that they took the entire corpus of text. So basically, they took the collection of books and they estimated the probabilities and stored it somewhere. So if I want to compute the probability, for instance, I want to get, but I can just query the probability of what is the count, number of times the phrase I went to occurred and number of times the phrase I went to the market occurred. So basically, based on the count, I calculate the probability of the proportion at which it was completed by market as opposed to the proportion to which it was completed in my sequence of text. One problem here is once I start computing these probabilities, they get smaller and smaller and smaller. So that makes it very harder. And other thing is, what if I have never seen sentence? The language evolves, right? The meaning of words evolve, the meaning of the way we write sentences evolve. So there are new terms which come into the vocabulary. There are new scientific terms. For instance, when these n-gram probabilities were calculated, the whole notion of diffusion models didn't exist in the popular narrative. So when I see, especially if you want to if you want to build a system for translation. So when I ask Google saying that, can you tell me, can I use a differential model to generate, to build a neural machine learning system? It says that it doesn't basically give you any result. The reason being is that it has never seen such a sentence. So according to that, the probability of me seeing such a sentence is 0. So it will never give you t. That's one of the drawbacks of such an n-gram model is that I always am dependent on whatever I've seen before. Whenever I get something which is novel or I've never seen before, I am not going to get any results here. So which is something which we don't want, right? So because the language keeps evolving, I need to, and there are always times that I use the same word in different senses. So my model needs to understand all these possibilities. So that's where we move towards building different class of models. And it also happens that as I increase the number of words, or if the size of the sentence increases, I also start having issues with how I calculate the probabilities. The probability of seeing 5 words is much smaller. If I go for 6 words, it's even smaller. So I need to handle such things when I want to build such systems. So now let me just. So like I mentioned, the simplest way, so people wanted to handle this. So the simplest way is basically what you could do is that if I am seeing a sequence of 5 words and I'm not able to find the 5-word probability, I use the probability of the 4 words here. So if 5 words is basically what happens is that if I have a pentagram, then I don't see the pentagram, I go and calculate the probability of quadgrams. If I don't see the probability of quadgrams, I go and see the of trigrams. If I don't see the probability of trigrams, I go and compute based on the bigrams. So the problem is that I go lower and lower and I make more and more errors as I go and utilize such probabilities. So either I could go to the lowest probability which I can compute, or I just do a combination of things. So if I can see a quadgram, I do a combination of quadgram plus bigram. These are again some sort of heuristics or hacks which were used in the early days to build such models. Again, the important thing to understand is that it's heuristics, so it doesn't capture whatever complexities we have today. So that's when we started building larger neural networks to build these models. The main issue is that what we saw is that I can see unseen sentences. Plus, I also can write a single sentence in multiple forms. For instance, let's take an example. The sentence is dog was running in the backyard. So I can also write the same sentence in a different way, but which which you would not see in your popular narrative. For instance, Puggle was polluting in the patio. The new sentence actually is quite similar to the old sentence, but if I'm just using the counts, I have no way to find out that these two sentences are similar, because the probability of the first sentence will be way, way higher, because that's how we typically write. In English, the likelihood of you encountering the second sentence in reality is quite low. So the probability of the sentence is going to be very less. So even though both the sentences mean the same thing. So that's what the problem is, that, right? I also want to know that I can use different words in the same context. For instance, if we knew that Puggle is a breed of a dog and polluting is nothing but an action verb for running around in patio and backyard are similar, I can actually use this to build better models. If my model can actually, so that's what neural networks offered us, is that it not only helped us to in some sense handle the unseen words, it also helped us to understand words which are similar to each other. For instance, if I rephrase the sentence, I still get a higher probability. It always assigns a higher probability, even though like it's written in a different form, even if the sentence mean the same, they will get similar probabilities. Right. So again, so these things keep going on. There are like a lot of examples which you could use. So that, and again, the other important thing is the larger the more size of the sentence we consider in n-gram language models, the larger the parameters which I have to use. For instance, if I just consider 10 words at a time to compute probability, as opposed to 5, I have to do a million power 10 minus one parameters. I have to build that bigger model. I have to maintain the parameters in my memory, which is going to be very, very expensive. So that's when we started building language models, which are based on neural networks, where I can basically, what I would do is that I compute some representation, real valid representation of given words. So that's where, if you go back, like embedding model, what we do is that given a word, we basically build a representation of the word. And instead of calculating n-gram probability over that, we basically, based on this representation, I actually build a distribution. I'm still computing the same probability, just that I complete it in a completely different way. For instance, let's take the same examples. If I say I went to the market, I just pass it through the embedding model, which gives me an embedding representation of each of the word. And then I pass it to a neural network, which basically gives me the probability of the next word. For instance, in this case, I want to calculate the probability of yesterday, given I went to the market. It takes the representation of the words I went to the market, and then do some computation, and then spits out the probability of this. So basically what happens is that when I'm training the model, I give it most probable sequences which I've seen. So for instance, what I could do is that I take the text from all the books which have been written, I just pass it through the model and ask it to regenerate the text for me. So by doing that, it learns it learns what are the more likely sequences it is possible, and what are different ways I write the same sentence, and what are the different words I can use in the same context. So for instance, it will learn a similarity between a puggle and a dog. So that's when it started happening. So that's where these are the earlier iterations of language models based on neural networks. But still, one important issue which it ignores is that there is always dependence between the words I have. For instance, I went to can actually determine which word I'm choosing next. For I went to will determine whether I'm using the or some other word, for instance. So that relationship between those things will not get captured in these models, where each of the word is now treated independently while computing the model. So that's where the next iteration of models, for instance, I want to take a very huge text, and all I am interested is in the last two words. So my model won't be able to capture the dependency of these two words on the preceding sentence, because I'm treating each word now as independent. So that's where the next iteration of models which came into picture, which basically said, instead of just getting the representation, I will also build some sequence into the representation, which says that I take the model and I use the representation of the previous word to compute the next word representation. For instance, you see here, as opposed to taking everything independently, when I'm computing the probability of yesterday, I also take into consideration of all the representations which I've learned till now. For instance, in this case, I take the representation of I went to the market when I'm computing yesterday, as opposed to where I used to just use I went to the market separately. I'm combining all the information to get the answer now. So these were the earlier iterations of models which started. I mean, these models have started having a different set of issues, which made it very hard for you to build it in large scale, build and deploy them in large scale. Okay, I will pause it here for a moment. If there are any questions here, I'll take them before heading into how the modern large language models are built.
Okay, we can take one or two questions.
Participants, the chat box is open now.
You can
type your questions in the chat box.
I see. Okay, so
no, you just disable this one, Kishore, chat box. Okay, so we will have, sir, we will have the questions at the end of the sessions.
okay. So okay, let me just go into the next part, right? So even now, what I am doing is that I'm trying to model a sequence of words as opposed to modeling word individually. What should now the point is whenever I'm computing the next word. So that's what happens in a language model. Given a sequence of word, I want to get the probability of the next word. Not all words contribute equally towards computing the next word. So what happens is then what I have to do is that I have to figure out some way to sort of compute the weight at which the words are weighted. That's what happens in something called attention. So what happens is that whenever you are given a sequence of words, it tells you how much each words contribute towards computing the next word. For instance, if you could see that I start with it, like when I'm computing the first word, I calculate what is the how much each word is computing. For instance, when I'm generating a new sentence. So let's say in this task, what I'm doing is that I'm taking a sentence and I'm generating an equivalent sentence in Russian. So whenever I generate a new word, you can see that there is a bar which represents how likely is this word computing or contributing towards computing the next word in the sequence. So so now the problem is that since the words are not equally contributing, I need to figure out a way to contribute to estimate this computation. And if once I have the contribution, then I can basically weight it based on how much each contribute, and based on that start generating the words for right. Then again, there are two ways to do it. It depends on the kind of task I want. If I want to do something like a translation, I'll take input in one language and I will take an output in another language. So for instance, here the input is in source language, the output is in English. So every time I calculate a word or I want to see the first word, for instance, I give the input in the source language and I want to calculate or estimate the output here. And what this is a translated sentence in English. So first, whenever I want, I calculate the first token here, which is basically this. Whenever I calculate that, I also calculate how much each of the input word contributes towards estimating the first sequence. For instance, if you see here, I'm saying the darker the color, the more it contributes. The word kore is sort of aligned with what this is. So then the word va is sort of aligned with what is. You can see that there's a one-to-one correspondence in which it is actually contributing. So it could happen that words doesn't contribute equally. It could happen the words contribute equally. It could happen that multiple words contribute equally. So what happens by doing this process is that not only I am using the previous words, I'm also computing how much each word is computing or contributing towards calculating the next word in the sequence. So either I can do that, or there are tasks. For instance, the task here is translation, where I'm giving the sequence in a source language and I'm computing the target sequence in a different language. For instance, here it's in English. I can also have tasks where the input and output are the same, where especially when I'm trying to train a model, I give the model whole set of text and I ask it to reproduce it. Based on that, the whole assumption is that by learning to reproduce the text, it is able to figure out the semantics of the language. For instance, here I'm giving English and asking to regenerate the English sentence. Whenever it tries, the whole idea is that if I show a lot of input examples, it will try to figure out what the grammatical constraints are, what are the semantics of English, what is the rules which govern English, what are the grammar rules. It will try to figure out by itself. So that's the whole idea of. So there are two kinds of attention. One is called cross attention, where the input sequence and output sequence are different, where you are basically having two different sequences. And there is something called self attention, where I am computing the attention with it itself. Okay, so when all this evolution started is when the modern architecture also started evolving. So every model which we have seen till now had its own deficiency. They couldn't scale up. They had their own set of issues. But what people realize is that the whole concept of sequence to sequence model, where I give an input sequence. Based on that, I try to figure out what the output sequence is still relevant. And not only that, whenever an input sequence is given, where input sentence is given, it is also useful to keep the information on how useful are each of the words in the input sequence to the output sequence. So that's what is called attention. So that's where what happens is that in 2017 is the initial iteration of what we see as large language models started. And we started building models conforming to an architecture called transformers, where it takes the input and transforms it into an input. In a very loose sense, it takes an input and it tries to learn a representation of the input. And while generating the output, it tries also to figure out how much each word in the input is contributing towards generating the output sequence. For instance, if I want to translate from English to Hindi, it takes each word in English for the given sentence, computes its representation, and it figures out how much of each of the input words in English contributes to each corresponding words when I'm generating it in Hindi. So if you see, there's a whole complex diagram here. We will actually go into each one of them, try to understand what each one of them are. So we looked at what attention is. Attention basically says, given an input sequence, how likely or how much each of the word contributes towards generating the output. And it could happen that whenever you give some input, it can possess multiple information. For instance, that some part of a sentence will have semantics. The certain part of a sentence will actually correspond to the syntax of English language. So I need the model to learn multiple different information. So that's where the term multi-head attention comes from, where instead of calculating using one way to find how each word is contributing towards the output, I learn multiple ways of doing it. So it could happen that one of the attention heads gets your syntax, other learns the semantics, the other learns grammatical rules, and so on and so forth. I have multiple different heads, each conveying different set of information, which can help me to disambiguate the output. For instance, again, we'll go back to the actual example which we looked at. We take an English sentence which is going to convert to Hindi. So it could happen that certain way the grammatical phrasing of the sentence can give you clues on what the first Hindi word should be, or the semantics or the subject-object relationship which is there in your sentence can give you different set of clues. So each of the attention heads, so basically different parts of the information gives you different contributions, and that is then used and combined to figure out what the next word is or the actual word in Hindi is. Right? So here is an example. You could see that I have an input sentence and output sentence, which is basically in this case, which is going to be the same. And I also sort of compute how each of them are affecting each other. For instance, the word making is of course going to affect making a lot, and more difficult is actually also contributing more towards the word making. So basically what you could do is, if you can take this and sort of interpret or visualize these weights or the values you are computing, that will help you figure out which are the important words which can act as context to disambiguate future generation. In our example, it can tell you which English words are important to generate the new Hindi words in the sequence of text which you are generating. Right? It could also, the one important here issue which we have said that we have taken here, we compute the representation of each of the word and we calculate how much each word contributes. So it can happen that the same word occurs twice in the sentence. So we still haven't, so what would happen is that it will generate identical values for each of the same words. Okay, right? For instance, let's say that I have a sentence which says a big dog and a big cat. Right? The representation which I'm getting, or it will equally weigh big in both the cases. But on an average, if you look at a big dog will be way larger than a bigger cat. So with I need to disambiguate between the what big means in the dog's context and the big means in a cat's context. So what we do is that we basically add some sort of a value to your where just basically I assume that I'm just adding a random number to the representation which I'm calculating, so that I can disambiguate between big when it comes to dog and a big when it comes to a cat. Okay, so we can skip over a few things in interest of time. So now the most important question is, how do I actually train these models, right? Let's say I have this, I know how I have a huge sequences of input and output. Now, how do I train these models? For if I want to train these models, what I do is that I take all the corpus of text which is available for me. For instance, I will go back to the examples. Let's say hypothetically, I have all the English books which are written. I have text from all the possible English books which have been written till now. I can take the text and give it to the model. The model will then try to reproduce the text. For instance, let's say I take this sentence, the cat slept quietly on the. It takes and it tries to reproduce each of the word. Given the, it tries to reproduce cat. It given the cat, it tries to reproduce slept. Given the cat slept, it reproduces quietly, and so on and so forth. The model then tries to see whether it can reproduce the text saliently, whether it can exactly reproduce the text. By trying to learn to reproduce the text, it tries to figure out what the semantics of the language is, what are the rules that governs English, how sentences are formed, what are the syntax and semantics associated with English. Once I understand, when a model learns how to take the words and put together and form sentences, then the model can start writing coherent text. That's the idea here. So what happens is that then once I start seeing such huge corpuses of models, the text and the model tries to figure out how to write English sentences. After the training process, hopefully it happens that it understands how to write an English sentence. Once I take and pass it to it, it tries to figure out the internal workings of a language, and then it learns to generate a language by itself. So once I have trained the model, what I have to do is that we'll go back to the same thing, right? We'll start with the sentence. The practice comma is what we started at. Then what I do is that then based on, I go and ask the model, what is the most likely word to generate. So it gives me more probable options. For instance, practice, he, great, influence. For instance, are the three, he, great, and influence are the three possible words. Based on practice, it generates, and it also assigns the probability of that being the next word. For instance, here it is 0.6, 0.2, and 0.2. Once I get that, I generate he. Then once I generated he, then I go back and ask what is the next probable word which I can generate. So he, practice, he, influence, had, and during is what then three possible options are. Then I go back and again pick the most probable word according to all the possible paths. So that's what internally happens to the model. First, the model sees a huge corpus of text. It tries to reproduce that, and based on reproducing the text, it learns the semantics in the inner workings of a language. Once I've then learned it, I can go and ask the model to do certain tasks. I can give a sentence and ask it to complete it. What it does is that it takes the words and tries to generate the next set of words. Once I generate the next word, it goes given the next set, given the initial sequence of word and the generated word, it generates the next set of words, and so on and so forth. So all these models internally do is basically predict the next. Given a sequence of words, it basically learns to predict the next word. And by doing that, we figured out that if I do it at a very large scale, the model actually learns the internal workings of different languages. Not only learns the different internal workings of different languages, it also learns similarities and dissimilarities between languages. For instance, it could learn the similarity between Hindi and Marathi, for instance, or any other similarly rooted languages or similar scripts languages, or it will also figure out how different are, what are the semantics, what are the grammatical rules that are different between two different languages. The whole idea here is nothing but in retrospect is fairly simple. You take the model, you give it large corpuses of data, and assume that it will learn the semantics of whatever you want to pick. So that's how most large language models are trained today, where you start with a model, you give it, introduce it, show it lots and lots and lots of text to start with, then it tries to figure out how to generate text in that language. So this is how these is how the initial versions of the models were trained, where they were trained for a certain set of tasks. So let's say when we started with n-gram models, which were done for very simple applications like just predicting the next word when you were typing in your keyboard. So that was the initial set of applications which they were used. The next set of models which were there were the models which I learned the representation of words, and based on that, I tried to figure out, I have a lookup, and then based on that, try to figure out what the next set of words are. Then came a generation of models where I try to figure out, try to train a model for a certain set of tasks. For instance, I could train a model to translate from a source language to target language, but I can only do certain or a limited set of tasks with these languages. So we started, as we go towards the right, I'm going towards a more generic model as we go towards the right. I start with a model which does only one set of applications, then started solving the issues with that which I encountered. Then as and when I started solving the issues, I started seeing models which would be more generic and generic as we go forward. For instance, when we started, the initial set of models would work only for machine translation, or would work only for a very simple set of tasks, like given a mail, whether to classify the mail as spam or not, or given a movie review, it will tell you whether the sentiment is positive or negative. So they were fairly simple set of applications, and these models had to be explicitly trained for such set of applications. As I built more larger and larger models, which sees lots of examples. For instance, the models today almost see the entire snapshot of public internet. So the entire snapshot of public internet is taken, it's crawled, you filter, and that is basically your input towards the modern language, which is used. For ChatGPT has seen few trillion tokens, which is almost a good fraction of the public internet and the books available to you. So based on that, they learn how to do, or they learn the semantics of the language. So once that is done, there are different process which takes over, which teaches the model to do tasks. So we will give a bird's eye view of what kind of tasks has been done, what kind of training you have to do, what are the parts of the training which happens, and what is the advantage or disadvantage of each part, what is the role of each part of training which happens. Yeah, I'm just taking a quick time check, like how much time can we take now, and based on that I will.
So you can take another 30 to 40 minutes because
okay.
It's 2:20, so you can up to go to 3:10 now.
Cool. Okay, so I will then go ahead. Yeah. So
Maximum.
yeah. Okay, got it. So I just give me a 5-minute time check. Based on that, I will also wrap up. Yeah. So we started from the left, where we built purpose-built model for a certain set of application. As and when we started building larger and larger model, what we realized is that we can build one model which can do multiple tasks. For instance, here there's a single model which does sentiment analysis, which generates English summaries. It also does translation for you. It also answers numerical questions. So we saw the evolution of more general purpose models, which instead of doing one task, you can have one model which does multiple tasks for you. For instance, now ChatGPT can generate code, it can generate images, it can also, some of the newer versions can also generate audio and video. Right? So we started training models which are more general purpose. There were one model which basically sort of fits across the spectrum of applications you can imagine. So initially we started with the left, which is basically again specialist model. Now we are moving to a generalization here. So what happened is that what we realized is that as I started building a larger and larger model, the model learned more and more tasks. For instance, if I started with a smaller model, it could do only like 5-6 tasks at a time. When I started scaling them, I started seeing that there's one model can do multiple tasks. For instance, ChatGPT has like few hundred billion parameters, and these as I see increase the size of the model, I see more and more abilities started emerging to the model. For we started with simple applications like summarization, sentiment analysis, translation, question answering, some arithmetic question answering. Then as I increased the model size, I started seeing more and more evolution happen. For instance, you could have a dialogue with the model. It can do code completion. It can do common sense reasoning. It started writing emails. It started doing a lot of things which are useful to you. That's the initial iteration of what ChatGPT is. So that's where we started with initial version of transformers, which had few billion parameters, which could do only a certain set of tasks. Where how we reached ChatGPT, where we just built a very large model which has seen a huge corpus of text, and the model by just trying to learn to reproduce what it has seen, try to figure out what are the semantics of a languages, what is the syntax, how do you put together a sentence, what are the grammatical rules which governs the language, and so on and so forth. In addition to that, what we actually started seeing is that we started seeing something called in-context learning. So until a few years back, when the initial iteration of models, when I wanted to do a certain task, I had to generate lots of data for that corresponding task. For instance, let's take an example of sentiment analysis, where I'm giving a sentence and I task is to figure out what the sentiment the sentence contains, whether it's going to be a neutral sentiment or positive sentiment or negative sentiment. I had to generate all such possible examples and then go and train my model to do that. What we started seeing when we built really, really large models is that instead of asking explicitly going and training the model, we could actually give it a few examples. For instance, I will give you 10 examples. You can go and give examples, some 10 examples to the model in the prompt. It started figuring out by itself how to do the task. As opposed to building specialist model, we were able to build generalist models which can take demonstrations based on what we give, and based on the demonstrations, it started learning by itself on how to do the task. I need not go in as an end user. It absolves me of going and training the model for each and every application. When I have a new task, what all I have to do is basically give it some examples, and based on the examples or demonstrations which I've shown, it tried to figure out how to do the task. So that's what was called as in-context learning. So there are two things which happened as we started scaling the model. One is that new model tried to figure out doing completely different set of and diverse set of tasks by itself, and a larger set of tasks. And it also tried to figure out how to learn based on demonstrations. Whenever a new task which is not seen during the training comes, you can just give it some demonstrations. Based on that, it figured out how to do the tasks. Right. So and not only that, it also learned to figure out, tell you how it generated the task. For instance, I can give you examples. It will also explain how it came up with an answer. For let's take an example, right? I give ChatGPT a prompt saying write an email for certain. So it not only would generate the email for you, you can also ask ChatGPT on why it chose to write it in a certain way. Or if you generate a program, you can also ask ChatGPT to explain the program and how it would work, what is the logic behind the program. And you can give feedback based on what it explains, and then ask it to iteratively improve the output of these models. Okay. So let me just pause here. So I have like 20-25 minutes, right?
Yes, sir.
Yeah. Okay, I'll give you a very quick summary of what we have seen now. We started with earlier generation of models, which were n-gram model, which basically tried to compute the probability based on unigram, bigram, trigram, quadgram, pentagram, which means 1 word, 2 words, 3 words, 4 words, 5 words. And we realized that won't scale, because as I increase the size of the models and as my vocabulary increases, I have to save a huge model in my memory, which is going to. Then we also had the issue that it wasn't giving similar sentences equal weightage. The sentences, even though they meant the same, some sentence which rarely occurred, would give a very, very less probability as opposed to a sentence which always occurs more prominently, even though they meant the same. So we then started building models which based on neural networks, which helped us to capture the relationship between the similarity between the words and the similarity between the sentences, and then which helped me to go one step further, which could build models for a certain set of tasks. For instance, I could build model for translation, sentiment analysis, question answering, and so on and so forth. But then what we started doing that we started building larger and larger models, we started with specialized models where we are going towards a generalist model. These models helps you to do multiple tasks at the same time. When we started building these models, we were building them at a small scale where we were just focusing on multiple applications, just combining all these applications. For instance, translation, writing an email, sentiment analysis, writing code. We were just focusing on a certain set of application. As we started scaling these models, building larger and larger model, we observed that the model is able to do multiple tasks at the same time as by just introducing a similar training process. Plus, not only do they do multiple tasks, whenever I can also give examples of some demonstrations to the model. It will also try to figure out how to do the task based on the demonstrations. Now, how did we get here? What kind of training happens to these models? So the model training happens in actually 3 phases. One is called pre-training, where you basically introduce corpus of text to the models. For a let's take an example where I have access to all the books which has been written in English till now. I just blindly give this input as an input to the model. So that's called pre-training, where I take a large corpus of unlabeled data, which is basically a collection of books, and I give it to the model and I ask it to reproduce it. I ask it to repeatedly reproduce whatever it has seen. So I give the model all the sentences in the books which I have seen, and I ask it to reproduce the sentences. So once it learns to reproduce by itself, then the idea is that by just reproducing it, the model is able to figure out what it takes to write a sentence, or what are the rules which are required to write a sentence. What is the grammatical rules? What is the syntax? What is the semantics? What is the subject-object-verb relationship? It tries to figure out what are the governing dynamics of a language. Based on that, you get a model. So then what I do is that once my model can understand English, then I teach a bunch of tasks for the model. I ask it, basically, I'll teach it to write emails, I teach it to do sentiment classification, I teach it to do translation from some language to English, I teach to answer question answers. Based on Wikipedia, I can basically tell it, saying, I can ask who is the president of the United States in a certain year, who was the prime minister of India in 2010, for instance. I can ask such questions, and I teach the model to answer these questions. So what happens is that, so once we do this process, it then figures out not only how to write sentences, it also figures out how to answer questions or how to generate response based on the prompt which I gave. Right? So other important thing to know is that these models don't see any language. By instance, that once you take a sentence, they won't see words. So they might see subwords. For instance, some words can be broken down into 2-3 tokens. Some words can be just maintained as, and again, that's a design choice that keeps changing across the model. GPT-3 might do it one way, GPT-4 might do it another way, and so on and so forth. The model needs to figure out how to learn an internal representation of any language or any task it is required to do. Yeah. So what happens is that, for instance, you take a sentence, I am working at IBM, it breaks it down into small parts. In this case, it breaks it down into I am work, and work is a separate word at an IBM. So basically, in this case, it is breaking it into base word and a subword, and an additive. A postfix here in this case. So I am working at IBM, I break it down into I am work, for the postfix here, which is and then at an IBM. So by doing that, it tries to also not only learn how to construct, it also learns to what kind of words it can prefix, what kind of learns it can postfix, and what are the possible postfixes and prefixes by looking at breaking down it into base words. And again, the breaking down is done specific to the model based on what it learned. There's a lot of other intricacies which we won't be going into in this case. Right? So Yeah. So what happens is that each of the model is now trained on few trillions of these words. The model initially when we started, we used to see few thousand examples, and as and when we could scale out, now each of these models sees few trillion words in practice. So for instance, ChatGPT saw some around 3 to 4 trillion words of combination of things in the sense different contexts. It need not be unique words, but words in a different context. So we create larger and larger corpuses, and this is uh, completely unlabeled in the sense that I only have the corpus as input. For instance, the corpus we are considering in this example is basically a collection of books. All I have is a collection of books, sentences which are there, which were written in each of the books. Let's say Harry Potter, the 7 editions of Harry Potter, I have all the text from the Harry Potter books. I use that as an input to the training model. Okay, so there were multiple ways to design the model, which we have now converged sort of into one way, which I won't go into, but these are the two popular ways. One is called an encoder model, the encoder decoder model, and this is called a decoder only model. Encoder decoder model is mostly used for translation, and decoder only model were used for other set of applications. But now everything has been converged to a decoder only model, what is called as GPT. Right. So now the point is now, right, by look at what I said is that the model just sees a whole lot of text and it tries to figure out what's the best way to learn how to generate these sentences by just repeatedly trying to. That's what we do, right? Sometimes what we do when we learn is that we look at the text, we try to memorize it, and then try to figure out patterns in the text so that I can easily retrieve whenever I want during an exam. I can just, whatever I've learned, I can retrieve based on certain clues which I have, certain contexts which I've learned, which some basically some sort of a hierarchy is formed in your mind, and that is what is used to write your exam. Whenever I prepare for the exam, I go through my textbook, I learn the concepts, I try to figure out and how connection between these concepts. Based on that, whenever a new exam someone asks me a question, I then retrieve based on what I've learned. And then so models sort of work in the same way. It sees a huge sequence of text. Based on that, it tries to figure out what are the semantics and the dynamics of languages. Once that is done, whenever I ask a question, it tries to reproduce based on the question. Right? So what happens here is that, so that's where, right, we start with a model where it's initialized to some random weights, where like if there are like 1 billion parameters, you just initialize each of the 1 billion parameters to some random number based on some algorithm. And then what happens is that then I keep seeing, what I do is I pass the first sentence and I ask it to reproduce the initial iteration. It is going to just produce garbled sentences. It doesn't understand the sentences yet. What I do is that then I see whether how correct or how close is the generated sentence to the input sentence. Based on that, I give a feedback to the model, and I iteratively do that. I give a sentence, I ask it to reproduce the sentence. I see how good the reproduction is. Based on that, give the feedback. This process happens repeatedly, and based on that, the model actually goes and updates its weights, or basically updates its beliefs. I mean, based on the belief, then again, as I keep repeatedly doing it, what we observe at scale, the model actually starts learning what the language is, what English, for instance, is, and then tries to generate coherent English statements. Yeah, let's just. So in this case, it's going to be unsupervised. That, like I said, which means that the input and output are the same. I send the English sentence, and I expect the same sentence to be generated back. So if you see, the input and output tokens are the same. Once I say I generate output ID, based on that, I calculate the loss. For instance, I ideally want it to be the same ID as before. What was the input is, if it's not, then I just penalize the model. If it generates the right sentence, then I just give a good feedback to the model. Then based on that, it learns to figure out what are the patterns and so on and so forth. And I just keep doing that iteratively. Right? So once I am done with that, I have a model which understands English, but it still doesn't know what a task is. It doesn't know what sentiment analysis is. It might not know what question answering is. It might not know what translation is. But all it knows is that there's a language to English, and I have digested lots and lots of English text. So next phase is where the training is called as model alignment, where I teach the model to do certain set of tasks. For instance, when I take a model which has only seen a certain thing, is that I ask, for instance, So some simple question, right? I have now only introduced the corpus of text. I haven't taught the model to do any task. I'm asking a question like, what is the sentiments of whatever the performance of the actors were abysmal. It starts generating garbage. It ideally, I just want an output whether the sentiment is positive, neutral, or negative. This happens because the model doesn't actually understand what it means to generate sentiment of a text. It understands the sentence, but it doesn't know what to do with it. So the next phase is where we teach the model to do task based on whatever your input it. For instance, I will teach the model how to do sentiment analysis. If I come and I will show during the phase, I'll show multiple input output pairs, and I'll teach the model to do multiple tasks. For instance, it could have lots of tasks. And based on the task you see, the more emergence you see. You could have multiple, yeah. Right. So these are basically what happens is that when we started training this model, what we ideally did is we took the existing data sets. For instance, we were used to building translation. We are used to building sentiment analysis. We have question answering data sets. What we did is that we took and repurposed the data sets to build one new humongous data set, which will teach the model to do multiple tasks at the same time. That humongous data set will have examples from translation, from sentiment analysis, from question answering. It will teach the model to do multiple tasks at one time. The hope is that it will try to figure out what is the commonalities between the task, and whenever a new task it comes, it will use those commonalities to figure out how to do a new task. So again, we do a same thing. As opposed to now, what happens is that when you notice that the input and output token IDs are here different. For the example is here, if I want to do sentiment analysis, I give a sentence and say, what is the sentiment of this sentence? The model output should be just positive, negative, or neutral. So I generate all such possible input-output pairs, and I give the model what is the sentiments of this sentence as input, and I ask it to generate whether it's positive, negative, or neutral. I do this repeatedly. I show it multiple examples. I do repeatedly. Then based on the output it generates, and again, I use a similar process and I generate output based on that. So whenever it gets an answer, I'll check whether it is getting the answer right or wrong. If I get the answer right, then I go and give a positive reward to the model. If it gets the wrong, I give a negative reward to the model. Based on that, it starts again, try to figure out how to do the task. So first, I've introduced large corpus of models with text to the model so that it tries to understand what the language is. Next, what I have done is that I've taught it to do. So once I teach it to do tasks, model then figures out how to do different tasks. For instance, then now I can just go and ask the model to write a code for you, or I can go and ask the model to go and write an email for you, or I can go and ask the model. I can give a sentence in English, and I can ask it to generate a Hindi sentence here. And so on and so forth. So that process keeps repeating. So what happens is that I can either do it at a different scale, where I do it at a task level, where the data set contains multiple tasks, or I just do it at a different level, where I don't tell the task, I just tell you a group of tasks and ask it to generate outputs based on that, where the generation is open-ended. For instance, if I want to generate a summary, the generation is open-ended, or if I want it to generate email. So these are the two popular categories here, where I know the input output clearly, or where I want to generate content which is open-ended, like writing a code, for instance, writing an email or writing an article. Those are all open-ended, where I have seen a lot of knowledge when I'm learning the model has to use the knowledge to generate such tasks. Yeah. So so that's predominantly the two more predominant phases here. And again, so then what happens now is that now I'm building a really, really large set of models, right? I see trillions of tokens during training, another set of trillions of tokens during instruction finding. I need to figure out how to train these models. And these models are trained in a specific hardware called GPU, which is basically a form of things or what you call popularly known as graphics cards. So the specialized version of graphics card are GPUs, which we take and which are basically purpose built for training these models, where you can actually do the computations which are required to training the model in an extremely fast manner and in a parallel in a fast manner. So that's what the whole point is that of doing it. Right? So perhaps this is a place to pause. And so how much time do you have? Based on that, I can just summarize.
We have around 15 to 20 minutes max.
Okay, so maybe, okay, so for the purpose of time, I'll actually skip these things. So I can then quickly go into, right? So again, there are multiple ways to train the model. One where I give input output pairs, where I just give input output pair and I ask the model to learn, figure out what to do. The other way is not only do I give input output pair, but I also explain the intermediate steps. For instance, if I want to write an email, you have it, I'll tell the model, it has to break down the task into simple steps. It then does the simpler steps first and then combines the output of those simple tasks to do a complex task. So that's what we do, right? Whenever we have a very complex task to do, we build it out into small set of tasks and we do the small set of tasks, and then based on the small set of tasks, we actually then combine to do a larger task. So we can also teach the model to do that. So what happens then is that the model not only generates some output, it also learns to reason its output. You can also ask it to that's when model learn to explain their output. It not only gives you an answer, hey, the sentiment is positive, negative, or neutral. It also tells you why it thought the sentiment is now positive, negative, or neutral. So that's what is called a chain of thought reasoning, where instead of just giving the question and answer pairs, I also give a chain of thought, like what we do, like how whenever we are set out to solve a problem, we have a chain of thought. We start to break down the problem, then solve the problem, we figure out how to combine the solution of broken down problems and then solve the problem. So we started teaching a model to do the same thing here. Then the model also tried to learn how to break it down and how to reason, and not only how to reason, it also learn to explain its output. It will also say, not only give you a sentiment analysis answer, it also tells you why it arrived at an answer, what made it to arrive at an answer, and so on and so forth. So the other important thing I want to do is that, so we have done two phases, right? The first phase, we have taken a very large model and introduced a very large set of model, basically passed the model and asked it to repeatedly reproduce the same input. The second is we taught it to do tasks. Once I do a certain, and I collected the corpus of multiple different tasks and I gave it to the model, and it simultaneously learned to do multiple different tasks at the same time. Now the question is, it could happen that the model can give you biased answers, or it can give you some disastrous results. You don't want the model to answer certain questions. So what we could do is that you can actually generate, whenever a model generates an answer, if you go to ChatGPT, it gives you an option to upvote or thumb up down, like vote up or vote down when you notice, right? So whenever you generates an answer, you can say thumbs up or thumbs down. So based on that, that is taken as a feedback for human preferences. So they generate preference data. So they also use that feedback to generate better outputs, which are more aligned towards what human preferences are. It could happen that if I give a prompt, the email can be written in like 10 different ways. But what is the best way to write an email which the human wants? So that is designed based on your thumbs up and thumbs down, which you rate in your model. That is used as the training data, and the data is then used to align the model outputs. Then based on that output, the model learns to figure out what are the human preferences, what are the most preferred way for a human to write such text. So that what started happening then is that even initially the instruction tuned models were generally generating coherent answers, but they were not human-like. So this step added an additional complexity, that not only I want to generate text, I also want to generate human-like text. So based on the preferences a human comes and gives me, I learn to do the task. Not only learn to do the task, I'll also do the task in a human fashion. Now the question is, when I have a model, so what I already have a model which is already trained, I want to do a task. So how do I decide how to do them. I mean, whether that model is working, or whether I should go back and change something about the model, or whether I should go and give feedback to the person who created the model. Hey, look, I am trying to do this and it's not working. So the first line of action is something called as in-context learning, which we looked at, which means that I give some demonstrations to the model and see whether the model is able to do the task based on the demonstration. If it's able to do that, great. Then we are good. We need not do anything else. Else, we'll have to go. It could happen that the model doesn't understand the task which you're doing. The model was not trained on the task which you're doing. It has absolutely no semantic understanding of the task if you do. So in that case, you have to go and retrain the model. You have to generate examples of the task you want to do, and then go and fine tune the model. And then let's see whether your performance is satisfactory. Then you can go and see if your performance is satisfactory, then you can go and use the model. So initially what we do is that we resort to what is called as prompt engineering, or RAG, or some post-processing, which is a forms of in-context learning, where we show some demonstrations and give some additional input to the model and see whether the model is able to do the task to my satisfaction. If it's not able to do it to my satisfaction, then I generate lots of data and go and teach the model to do the task. So once I teach the model explicitly, then it starts learning to do whatever task I want to do, then I can use that model. So this is basically, just to summarize, this is what happens in a different phases, where the first phase, where you something called pre-train, where you basically teach what are the general concepts are to the model, different language skills. You basically teach what is English, what are different concepts, what is physics, or what are the concepts in physics. For instance, what is reflection, you teach all these things. And so that's the first phase. And the second phase, where you teach domain-specific concepts. You can also introduce English sentences from medical domain, and you can teach the model what is fever. You can teach the model what is inflammation. For instance, it then learns based on the domain-specific knowledge. Once it first learn the language, then it learns domain-specific knowledge. Then you go and teach the model how to generate, or how to do tasks, or how to utilize the knowledge it has learned to do tasks. For instance, let's say I build a medical diagnosis system. I want the model to generate, given a bunch of symptoms, I want the model to tell me what kind of disease I have, for instance, just hypothetically. Then I generate such example, and I teach the model to do such tasks. So once I've done that, then I can take the model to deploy. So what happens then is that the model then not only learns to do the tasks which I've taught it to, in many cases, it also learns to learn from demonstration. Then I can take, even though I am not explicitly taught the model about certain set of diseases, you can give some examples on diagnostics for certain set of diseases. The model will try to figure out how to diagnose such diseases, for instance. Yeah. So now the most important question is that, hey, I've now built the model. How do I evaluate the model here? I want to figure out whether the model is able to do what I want. So there are three ways to do it. I will go into detail. And then first is, even before going into three ways of doing it, I need to figure out what my metric of success is. I want to generate data that I want to make sure whatever data I'm using to evaluate the model is not seen during training. I not only do that, I also expose the model to a bunch of people and ask them their feedback. Then I go and test it. So I decide on what is the success metric, then come up with the data, make sure the data is not seen during training, then generate what I do is that I do the evaluation study, then show the outputs to the user and take the user's feedback, and then go and test it. So there are three prominent ways to basically test the model. When is that I go and see whether the answer, for instance, what is the question? Or the question here is, what is the capital of India? The answer is New Delhi. I want to make sure that the number of times the option A has the highest probability is quite high. I count the number of times the option A is with the high probability. So that's one way of evaluating it. And then there's also I calculate some automated metrics called perplexity, which tells me what is the likelihood of A, what is the likelihood of B, what is the likelihood of C, and D. I want the likelihood of A to be the lower the perplexity, the better the generation is. Or I can basically just ask the model to generate and see whether it's generated the right answer or wrong answer. I can just give them a question. I see the number of times it has given me the right answer. Ideally, I want it to be correct as much as possible. So that's the most simpler way of evaluating the model. There are more complex ways of evaluating the model. There are now leaderboards which show it takes the model, asks the model certain questions, and asks it to generate answers. Based on the generated answers, it computes some metrics, and there are leaderboards. If you go and see for LLM Arena, there are multiple such leaderboards. It tells you which model is doing well for what kind of tasks. Most of the benchmarks which we use are basically a combination of tasks and which are on different languages. For instance, the most of the benchmarks are used today are multilingual, and also not only multilingual, they also have examples of each of the tasks in a different set of languages. So it not only can I ask you to write emails in English, you can also ask it to write emails in English, English, Hindi, Spanish, French, whatever languages. It has examples from different. So that not only I figure out how good the model is at doing certain tasks in English, I also figure out how good they are in different set of languages or how good they are in responding to different scenarios. Yeah, so I will pause here. Perhaps, yeah, take some questions here. And then I could summarize. Is that
Deepak sir, we have a question in the mailbox. I'll paste it in the chat box.
Okay.
From PALS champion Murli sir.
Okay, I am 1 minute. Just
Mr. Murali, if you want to ask question, you can unmute and ask.
I
Because
pasted the question in chat box.
okay. So
No, it's a very general question. I mean, very primitive question to me. How do you select just telling? Because I happened to read something related to the model architecture to select a language model. So I was asking about that question. I'm not quite sure whether it has been already included in the presentation. Anyway, go ahead. I'll try to decipher. My question is not very important when considering to the other people's participation. Just go ahead and certainly I will.
I'll start with that question. Perhaps I can go. So a different architecture. Initially, when we started, there were multiple different architectures which we were playing around with. But currently, everything has converged to a single architecture. What is the difference is that how efficiently we are doing the computation. Everybody has their own way to efficiently do the computations which are required to train the model. That's where large differences come into picture. The way they train the model and the way computations are done when it comes to efficiency is where large differences lie between how ChatGPT works to what Gemini does to what Llama does, as opposed to the architecture. Architectures have largely converged towards decoder only transformer architecture. That's the famous one. That's what people use nowadays. And how to train models. Okay, this is regarding frameworks, right? The most publicly available ones is PyTorch. So where if you want to train a model in PyTorch, there are a lot of libraries which are available, which you could do. So if you are interested, you can look at something called transformers from Hugging Face and its associated libraries. If you go into the repo, there are a lot of examples on how to pre-train, how to fine-tune the model, what kind of data to use. And if you have the GPU resource, you will be able to take and play with a toy model and play around with it. So that's something.
Thank you, sir. There's
Thank you very much. Thank you.
There's another question from Vijay from Alpha College.
Okay, medical students to form. Okay, so there are not publicly available models. There are tools which are available as of now, but most of these existing models are reasonably well enough to do medical, not for medical diagnosis, but they are a general purpose thing. These medical diagnostic tools are actually closed door. They are not publicly available.
Okay. I'll open the chat box now. Students can type their.
Wait, Kishore. We will do it in the end. So, Mr. Deepak, you can summarize that the thing. And then we will ask. We'll open the chat box later, and we'll finish that slide also once you are done with that.
Yeah, just 1 moment.
I think Madhusudan. Okay, 1 second. One more question from the champion.
Yeah, let me just check it.
Okay, Kishore, can you co-host Madhu Vyaha? Mr. Madhusudan has joined. He wants to ask question.
Madhu?
Madhu Vyaha. Madhuvy.
Okay.
Yeah. Yes, Mr. Madhu, you can unmute and ask
Yeah,
your question.
thank you. Thank you. Very, very nice talk. Really very, very topical. Thanks, Deepak. So a couple of questions, sorry. One is, so most of this training has been done just by scraping data from the internet, right?
Yes.
So in theory, any company could be able to do it, isn't it?
Yes. So
So,
that's,
and
yeah, please go ahead.
yeah, and secondly, now the Chinese have shown that we don't need such a large bank of GPUs, etc., etc. So Indian companies should be able to challenge. That is really the question I'm getting at.
Yeah. So yes. So there are a lot of intricacies involved. Once I scrape the entire internet, I also need to invest a lot of effort to clean the data. So, I mean, it could happen that there's a good bunch of noisy signals available on the internet. So I will have to write pipelines to clean the data. And once I have pipelines to clean the data, I need to build the frameworks to train at scale. So most of the publicly available ones are sort of lacking. So if you want to scale to 100 billion parameters or those kind of models, I will have to optimize my code to build to work on that scale. So, I mean, it's certainly possible for us to do it by anyone. And it should be possible. So there are, let me give you an example. So there's a company called Sarvam AI, which does it for Indian languages. So if you
Okay.
look up, so they build small models. They don't operate at scale. They build around 2 billion kind of model, 2 billion, 3 billion kind of models. But their task is fairly simple, is that they wanted to do it only for Indian languages. They want to have models which can, for instance, answer your questions very reliably in Hindi, Telugu, Tamil, Kannada, or whatever languages, or all parts of Indian languages and dialects. So that's the challenge they've taken on board. And so we also have an effort to do it for Indian languages. So there's nothing stopping us from building our own model. It's just that we need to build the infrastructure and the team to do it and build our own pipelines, which would take some time, and then we'll also be set.
Sure. Thank you. Thank you.
Okay, thank you, Mr. Madhu. Yes, Mr. Deepak, you can summarize quickly and we will have a slide after that.
So just to summarize is that, so what we see is that we actually need, we saw first how to train the model, then teach the model, which is called pre-training, where I introduce the concepts to the model, different language skills to the model, introduce different languages to the model. Then we looked at how to teach the model to do certain tasks. For instance, how to write emails, how to do sentiment analysis, how to do translation. Then once I did that, what if I want to use knowledge which are not available to the model? For instance, let's say the model was trained in 2023. I want to use a knowledge from 2024. So I can also sort of retrieve more relevant or more newer things. I can search the internet, get newer articles, use that, give that as a context to the model and ask it to answer questions. That's called retrieval augment generation. And the other part is where I teach the model, right? I told you where you can teach the model by demonstration. I can give it some examples and I teach it by demonstration to do certain tasks. So in this lecture, we just looked at the bottom of the pyramid. The subsequent lectures, my colleagues will teach you how to basically take a model, deploy it, and play it around within your laptop. Currently, most of us rely on using public interfaces, right? I go to chat.openai.com to interact with ChatGPT. But there are smaller models which I can run in my own laptop and play with and interact with it. So one session, we will introduce how to do that. In the subsequent session, how we will teach you how to do prompt engineering. What is the better way to ask the model? How to phrase the question? What is the better way to do that is one of the things. And let's say I want to introduce new knowledge to the model, which was not available to the model during training, how to do that. So that will be the subsequent sessions, which my colleagues will be offering. So that's the overall high level summary of what is going to happen, what we have looked at, and what is going to come in the future.
Okay. You are done, Mr. Deepak?
Yeah. So that's sort
Okay.
of something. Yeah.
Okay, I will share my screen. So participants will get into the Slido straight away. I will share my screen. So Kishore will be pasting the okay. So people are joining. So we have around 67.
It'll be good to register and get into Slido because that is one of the prereqs for your certificates in future.
So we have 694. Okay. So I'm starting now.
Out of 694, how many have joined? 100.
700. 700 is joined as of now.
Oh, very nice. Excellent.
So we will start the quiz. Your first question. So you have a 25 seconds. Just go to your browser and answer there. So don't see the Zoom screen. So you have a 25, 18 seconds. So what does an embedding model do? So you have 4 options. So we'll see that. So 54% have answered C. Let's see which one is right. Yes, that is the right answer. So we'll move to the second one. So what is a language model? You have 4 options. Assigns probability to a sequence of text model to generate an image. Provides numerical representation of image, text, or audio. Model to generate audio. Just answer from your browser. So don't see the Zoom screen. So when I say you just come to the Zoom screen, then you just come and see the leaderboard. Okay. So option A, many of them answered. Yes, that is the right answer. Okay, the third one, what is an n-gram language model? You have 4 options. So you have 4 options. It assigns probability to a sequence of words, calculates the probability of a word based on previous n-1, and it provides numerical representation and model to generate music. Let's see which one. Okay, many of them answered B, 77%. Yes, that is the right answer. Fourth one, why do we use smoothing and interpolation? So you have 4 options. So many of them, so it's a neck to neck. 36% and answered A, and 35% answered D. So let's see which one is correct. Yes, answer D is correct. The fifth one, why do we need a recurrent neural network based language model? So you have 4 options. Learn long range of dependencies, handles noisy words, generates images to handle unseen words. Okay, 79% answered A. Oh, that's correct. Let's see the leaderboard. You can, yeah, so Aditya G, B, Selva Lakshmi, Jagannathan P, and Pavani, that is headset, that is good. So that is a good practice. You have to give your name hyphen your short college short name. So it will be easy for identification. And fifth one is Niharika.
Congratulations.
Yeah, we'll move to the sixth question. So what is the difference between cross attention and self attention? So you have three options. So very good that it's 800 plus participants are participating in this Slido quiz. That is good sign. Out of 900 plus. Oh, answered B, 89%. Yeah, that is the right answer. Seventh questions, we need multiple heads in a transformer to capture different diverse aspects of an input. You have either option, that is yes or no option. Okay, 94%. Yes, that is the right answer. Eighth question. We need positional encoding to distinguish between identical words in a sentence. Again, yes or no option. So let's see which one is correct. Oh, that is also 80%. Yes, that is the answer. Ninth question. How do we pick the next words while generating a sequence of words? You have three options. Pick the word with the least probability, with the highest probability, and word at random. Okay. So 91%. This answer B, very good. So the final question. So what is the advantage of using LLMs? So you have three options. Can do one task well, can generate images, its own model to do many tasks. Okay. Answer C, 92% have answered correct. We'll see the leaderboard. Okay, congratulations Aditya G and Shreya. Yes, I don't know which college you belong to. Jaswant Raj and Pavani, that is Hindu College of Engineering and Technology, Sunil T. So
Congratulations.
Kishore, over to you. Now participants, you can ask your questions. So I think chat box is enabled. So if you want to ask, you can raise your hand option also. We will unmute you. Okay, so Vijay Devaraj. Mr. Deepak, one question has come from this one from the mail, Ask Pals PMO. Sir, is there any generative AI tool is available for medical student to perform analysis and prediction on medical?
Sir, that question has been answered, sir.
Answered already. Vijay from
Answered already.
Okay, one more question.
In chat box from Khalid.
Yeah,
Khalid.
go ahead.
If the model's working only on finding next probable word, then how can they be used for conveying certain thoughts or given an answer for a question?
Let me take that. And yeah, so the whole idea here is that your training happens in three phases. First is that you introduce the entire internet corpus as input, and then you teach the model to do certain tasks. During that phase, it learns to figure out how to give you an answer, where you give a prompt, like, right, you will basically show different kinds of tasks. You will give thousands of tasks as example. Then where the model learns to do the task, not only they learn to do the task, they also learn to connect the different set of tasks, and based on that, it tries to figure out how to give you an answer to the question. So one of the tasks which is prominently used is to answer the question. So that's how they learn to answer the question. And for using conveying a certain thought, that's where the third phase come into the picture, is that when the model is deployed, you ask a question, it gives you an answer, you give a prompt, you give a response, you give a thumbs up and thumbs down, right? So based on that, it learns to figure out what your preferences are, what are your thoughts, how do you want the answer to be phrased, and those kind of preferences are learned in the third phase. So this typically not only when before for instance, in the case of ChatGPT, before deploying, they recruited lots of people to give them feedback. Based on that, they train the model. And even during the deployment phase, wherein you interact with ChatGPT, if you notice, there will be an option to regenerate, you option to give the thumbs up or thumbs down. Based on that, they will figure out what your preference is, and then they incorporate that in the next iteration of model training. Okay, what will be the outputs of while LLM? Okay. So there are, again, the output depends on what phase of training you are. In the first phase of training, which is called pre-training, the output and input of the model are the same. In the second phase, where we are teaching the model to do a certain task, the input will be your prompt, and the instruction output will be the task output. For instance, if you want to translate an English to German sentence, in your input will be, please translate this English sentence from English to German. Give the English sentence. The output will be the corresponding German sentence. Okay. Okay.
There's also a question from Lizard. There is more fake data on the internet. How ChatGPT identifies the real data from the fake one?
So what happens during the training is that there is always a filtering phase. When I crawl the internet, there is a team which sits and filters the data, which tries to figure out what is fake data, what is actual data, what is valuable data while training the model. So that gets filtered out during that phase. How in search and language, but no, how the model identifies search. So the model learns when during the training phase itself, the model is introduced to different languages. Most of these initial version of the models were only trained in English, but most of the current generation of models are trained from the entire internet, where the examples are of different languages. So whenever you give some input in certain language, while just learning the semantics of the language, it also tries to identify the language. During the training process, it implicitly learns to figure out whether the input is in English, French, Hindi, whatever.
Sir, one more question from the mail.
Yes.
He's Vijay from Alpha. In certain scenarios, enemy aircraft can evade radar detection by deflecting radar cross sections or using systems that absorb radar waves. What technologies can help detect such capabilities, and what actions or updates can be implemented to counter their situation and prevent similar occurrences in the future?
Okay, so these kind of things are actually beyond the scope of what language models are. The interaction of language is through language, either through audio or video or image. So anything which is grounded on sort of language. So these kind of models would require specialized models to be deployed just to train. You want to collect data for just those kind of occurrences, and you have to train the model for those. So these are beyond what LLMs can currently do. Perhaps a newer generation of model which would come, which could do such things, but currently they are not capable of doing such stuff. Are there any other questions?
Greeting, sir. I am from Beta College of Engineering. My question is how...
College of Engineering here.
Yeah,
that itself is a fake question, so we can
okay
pass through. Yeah.
One more question. Does the government regulates the things AI can do?
Yeah, so the regulations when it comes to AI is quite nascent. So everyone is working on their own set of regulations as of now. Like even government is trying to figure out what is the best way to handle AI, what is the best way to handle copyright from AI content. There's no one answer here, but even they are trying to figure out. Every government has their own committees, their own expert committees who are trying to figure out what's the best way to regulate AI. There's no one answer here as of now. Just even they are trying to figure out things as we go.
Okay. Any other questions from the champions?
There's another question, sir. I am from Sigma College of Engineering.
Hey, don't read it that.
Okay.
Champions, you just disable the chat box. So champions, if you have questions, you can ask Mr.
How does ChatGPT handle bias in its response? One question.
Okay. So that's handled in the third phase, where what we do is that when we generate something, we ask the preference for the user, right? So in the sense, like I generate, let's just take an example. I ask it to generate an email saying I want to write an official email to my manager to do so regard certain thing. I'll generate a response. So whenever the model generates a response, model also asks for preference. So that preference data is what is used to figure out whether it's biased or not. So we call this as human preference alignment, where we take the human response or human preferences for each of the training or generated output. Based on that, we do and give feedback to the model saying, whenever you are asked to write an email for a certain form, a human prefers these kind of responses as opposed to these kind, like response A as opposed to response B. You should prioritize generating response of kind A. So that's how biases are typically handled. That's still again a simpler way of doing it. That's an open question to actually generate a bias-free response for any LLMs.
Okay. I think no questions.
I have no more questions.
Deepak, just a small.
Yes, go ahead.
And your one of my first question, you are mentioning PyTorch is one of the popular framework for training language models. You are telling.
Yeah.
I have not touched it, but I read somewhere TensorFlow is also. Is it applicable TensorFlow for any such things?
Yeah. So TensorFlow is possible. It's just that the ecosystem around PyTorch is way more richer. For instance, if you get stuck somewhere and you want help, the possibility of you finding help in PyTorch is larger as opposed to TensorFlow. Now, PyTorch is the most famous one, so most people use it. If you run into some issue, you can just Google. Somebody might have encoded. They'll find it. They fix the bugs quickly. Plus, there are also tools which will help you to build over PyTorch. So that's why publicly, when you're building models, PyTorch is a preferred thing.
Thank you. It's a wonderful presentation by you. Thank you very much.
Thank you.
Shall I go ahead?
Yes, ma'am. You can go ahead.
A big thank you from all of us, the PALS team and the delegates from both students and faculty members from our partner institutes who participated in large number. It's a great record, I should say, with 1,000 people attending online here in Zoom and another 450 plus in the YouTube. And we thank Deepak for setting the context and giving us a great introduction to the 4-part series. Thank SKK and my colleague Pati for doing the introductions and the arrangements. We thank the core team members who are here, Professor Murli, Madhu from Hyderabad and all others who had participated actively. And thank you all for being here. We look forward to your presence for the next 3 parts as well. So have a good evening and thank you all.
Okay, so participants, we have.
Thank you.
Thank you, Professor Murli. Participants, we have posted the feedback link in the chat box, so please submit the feedback. And the next session will be on 7th February, so same time. So the topic will be granite model serving on a laptop. Mr. Mahant Kamakoti, research software engineer, IBM Research, will take the session.
Request the participants to kindly submit the feedback and leave.
Remember, it's a prereq for your certificate set later on. So your attendance, participation in Slido quiz and feedback are important to get your certificate in the final after attending 4 sessions.
Kishore, I hope you have posted the feedback link in the YouTube as well.
No, sir. I can't post because I don't know why.
Wait, I'll do that.
Thank you. Thank you, Honorable.
Thank you, sir.
Yeah, I have pasted feedback. I think you can stop streaming and you can stop recording.
So 10 minutes wait panni recording close pannirava. Sorry, meeting close pannirava.
Yes, you just wait for 2 minutes, then close it. Almost 24.
I'll wait till 3:30 and I'll close it.
Yeah. Okay. Shall I log off?
Yes, sir.
Okay. Thank you. Thanks, Kishore, for your moderation.
Okay.
Yeah, so I can also move on. Like,
Yes, sir. Deepak.
thank you.
Thank you for your session, sir. It's a wonderful session.